Okay, we're going to turn this guy that we made in blueprints into C++. So we've got a two-dimensional South Park little dude. He can jump, move around, and he's using sprites, but in 3 dimensions. And we made it all on the event tick with this little animate function right here. You can see the other video in order to how to put this together, but we're going to do this in C++ now, and it's a lot neater, and it won't be on the event tick anymore. So we're going to make a new C++ class. Let me refer over here. Yes, new C++ class. It is going to be of a paper character. We're going to call this animation character public. Create the class. And wait for it a little bit as it compiles. Grab yourself some green tea, perhaps. Ah, that's hot. Any day now. So how about those GameStop stocks, huh? Yeah. Might want to grab something to hold to the moon and back again. All right. We have our... Where did it put it? Why is it over there? That's not what I wanted it in. You're a different window. You over here. I use Rider, but this will work with Visual Studio as well. This is Rider for Unreal's pretty nice. Check it out if you haven't. Okay. I'm not going to explain C++ because I'm just going to build stuff. We need this character. If you remember, basically we're going to copy this guy over. So he's got these things come with the paper character. We added these on, so we need to do that. I'm going to stick those under a protected. All right. We need a class U spring arm component. Spring arm component. And we need a class U camera component. Both of these will be U property, visible anywhere, blueprint, read only, I believe. I think that's all we need. Oh yeah. Category, components. Copy, paste. Okay. And then over here, we need a constructor, animation character. We're going to set those up. I assume this paper character's coming with those other things, so we will... It is a character, so yeah, it should have those other things. Okay. We need to get our spring arm component set up. Spring arm component, create default sub-object of a use spring arm component. Name it spring arm. Spring arm component is set up attachment to the capsule component, I think. Get capsule component. Maybe just root component. We'll see if that works for now. And then the camera component, camera component, create default subobject, view camera component, text camera. And the camera component will be attached to the spring arm component. We're going to give the spring arm component target arm length. I shortened mine from what I did yesterday, so we'll do 500. There are some other things we need to remember to turn off, which was these guys. All the inherits need to be turned off. That was on the, yeah, spring arm. Spring arm component, inherit, pitch, false. Inherit, yaw, false. Inherit, roll, false. We wanted a little bit of lag. Where is it? Be enable camera lag. True. Spring arm. Enable rotation. We didn't use this, but in the other game, I had made it so that you could actually click down on the middle mouse button and give the camera a little bit of rotation left and right. You can clamp it. I might make a video on how to do that so that it kind of moves a little bit from here to here, so you can kind of move around the world and see stuff from a different angle while still maintaining on a two-dimensional plane. So that's what that rotation lag will give. And then I had a speed for those 4 and a distance of 600. So spring arm lag speed equals 4. Spring arm camera rotation lag speed is 4. Spring arm lag max distance was 600, I think. Okay, that should set that up. Let's go ahead and compile that. And we're going to make a new blueprint off of it. What was it? Animation character. BP anim character. Yes, okay, so we do have these guys in here. Perfect. We have our arm and our camera exist. Wonderful. Let's make sure that that is rotated properly. Let's get those settings. So our spring arm was set to a 0, a negative 30, and the, I never remember these, pitch. Okay, so roll 0, pitch 30, negative 30, and yaw negative 90. So let's go ahead and get that written in here. I like doing those transforms above. Set relative rotation. F rotator, it goes in pitch, yaw, roll. Roll was 0. Pitch was a negative 30, and yaw was a negative 90. Okay, compile that. Jump back. Oh, and that happens all the time. Anytime you, Unreal does not like hot reloads. Or did it? Oh, no. Yeah, it's gone. Where are we? And yeah, go ahead and restore. It couldn't. It doesn't know where it is. It doesn't matter. We're back. just have to make our blueprint again. Animation character. Save and save all this time. You exist. I did that wrong. Interesting. Pitch, yaw, roll. Oh. Okay, so yaw should be -90. I thought I had these in the right order. And pitch is the X. We want that up, and we want nothing rolling. We're going to save all. This might crash things again whenever you do stuff like this. Yep. Come back. I literally donated plasma like 30 minutes ago, so if it seems like I'm doing things in an odd order, or if you know how to do things better, just shout at the screen. Just yell at me. I will hear it eventually. Hey, there we go. We've got a camera. Alright, so let's go ahead and do similar things. Our down idle. Bump our sprite up to a 13 scale. Lower him down a bit. Let's make our capsule nice and fat and round. That is it for the setup on this guy. Now we need to make the animation logic, which is fun because it is so much cleaner and easier than the blueprint. What we're going to do is get ourselves two functions, a U function, just because you might want to call it someday. It's blueprint callable, and we'll put it under animation character animation, and we're going to call this void set current animation direction. Is an F, it wants an F vector. We're going to make it a const reference, and we'll call that velocity. That's how we're going to set our enum, which, by the way, we need to make in C++ as well. So here we go. I'll show you how to do that too. And you could do this in a separate, but since this is just an example, I'm going to do it in the animation character header. I would make this in a separate types header if you're going to have structs and enums that your project's going to use overall. But we're just going to make an enum here, call it blueprint type category. I don't know if this category does anything, but I saw other people have it, so mine has it. Enum class e animation direction. It's going to be of a uint 8. Boom. We need to have up. And you could toss in this so that there's a different display name than the actual variable name. Don't think we really need that. The only time it differed was a space on the upper left and upper right. Down, left, right, upper left, upper right, down left, down right. So that's our enum, which we want to have one of those. This is going to be visible anywhere, and blueprint read only animation character config. It is of the E animation direction. This is our current animation direction. We also need to make that struct of our flipbooks. We'll do that up here as well. We need a ustruct blueprint type category. Again, probably, I don't know where that ever comes up. Struct F animation flipbooks. Generated body meta thingy, macro, whatever. And we need a bunch of U properties, which are going to be edit anywhere and blueprint read write. The blueprint read write's not, you could change that later. It is of the type U paper flipbook. Whoop, flipbook. And the first one is idle up, and we're going to make it a null pointer. We're going to need to include the paper flipbook.h. There it is. This goes down here. A paper character using the fancy 2D animation sprite styles of popular cartoons. We need to have one of these again for every direction. We're going to go down, left, right, upper left, upper right, down left, down right. And these are all for idles. So this is idle down, idle left, idle right, idle upper left, idle upper right, idle down left, idle down right. You now need all of these for walking. Walk. And look, copy, paste, paste, paste. Meanwhile, people who use Vim are screaming at me. There's an easier way to do that. And that is it for our struct. So we've got that. Let's toss him down here as well. It's a U property again, visible anywhere, blueprint, read only, category, animation, character, config. F animation flipbooks are, we'll just call this our flipbooks. And okay. Now, along with this function is going to be setting our enum. We need another function, our main one. This is our blueprint callable, category equals animation character animation. Could have just copied that. Void, we'll call this just animate. This needs a parameter of float delta time, f vector old location, f vector const old velocity. Whoops. And that is all we need currently, yeah. Okay, so let's go ahead and implement these. And I'll switch to implementation over here. We want to set, let's see, our current animation direction. Let's set that up as E animation down. So that's initialized there. Flip books. We're going to do that in the editor because I don't like using constructor helpers. I'm supposed to avoid those as much as possible, apparently. We're going to need movement input. I forgot about that. So over here in the header, go ahead and this is an override, so add movement input override. This is how we're going to get off the event tick. We are not going to be calling animate on the event tick. It's going to be done dynamically off of add movement input. So in the constructor, we're going to do on character movement updated, add dynamic, this a animation character animate. So this on movement updated, if we go into it and find it, anyway, you can dive more into this. On the character, it has these multicasts that is called every time the movement is updated, as it, self-explanatory. So our animate will then be called every time movement is updated. So that takes it off of the event tick. In this add movement input, pawn movement component, we're creating one. Get the movement component. This will return the off of the character. It'll get our pawn movement component. We could probably auto this if you wanted to. Some people don't like those. I try not to use them too much, but in moments like that, it seems okay. And if we have it, movement component, we're going to add input vector. We get the world direction from the parameter. We'll multiply it by the scale value that's coming in. And b-force we're passing in as well. If we didn't have a movement component, there's an internal add movement input, which again, world direction times scale value and the b-force, if there's any force being added. This internal is, I believe, on the pawn rather than, yeah, it's kind of similar. I don't remember where I saw this or where I got it from, but this is if there is no character movement component. So if you have a pawn, this will do it. Okay, let's work on the set current animation direction. We are going to get our x and our y from that velocity parameter. So the x is a const float, x is equal to our velocity, get the safe normal, x. So we're normalizing that, right? Yep, get a normalized copy of the vector. So this x value is going to be within 0 and 1. Yep. And a float y. This is going to be modified, I believe. Yeah, we're running. Yep. I change it based on mine because I do something pretty cool that I might return to later, but for now, we're not going to do it in this video, so we'll const it. Alright, so we've got our x and our y's. I just realized I don't know if you guys can see this stuff, so let's bump up. That's the issue when you have a big screen. Okay, we need a Boolean. Add a quick Boolean over here of, and I do it this way. U property. We're going to do visible anywhere also again. It's blueprint, read only, category. Because typing, you know, you got to practice. This is saying I have an unsigned integer of 8 bits and I only want 1 bit of it. And then in the constructor, you set it up so B is moving is false. So that's how Unreal Engine it saves memory, I believe. It's faster rather than doing a bool. You just do a 1-bit int. So this is our check. B is moving is equal to x not equal to 0.0 or y is not equal to 0.0. That's it. Are we moving? If we're moving. This is where we're going to take all of this stuff and we're going to dump it into C++. First, down. If our y is greater than 0 and let's keep this consistent, and the absolute value of x is less than 0.5 or x is equal to 0.0, then our current animation direction is E animation direction down. Again, downwards y increases, so towards the camera if we're moving down on a screen. And then if our x are left and our right, if we're within this 0.5 safety zone, so we're checking if we're not moving a little left or a little right because we don't want to use those diagonals. We're just going straight down. Or x can also be just a flat 0, which we don't need, that I realized in that last video. I clean things up as I describe them. It's, you know, I'm learning with you. It's great. If that's not happening, and y is greater than 0.5, why do I have it greater than 0.5? Oh, I know. Because this is also checking for left and right. We want to make sure that this is, again, just like we have a safety for left and right for going downwards, we also need to be safe if we're going straight left or straight right. X is less than -0.5. Our current animation direction becomes E animation direction down right. Next, else if y is still greater than 0.5f, so we are going down, is x, my bad, my eyes skipped ahead. This is the greater than 0.5, this is less than -0.5 down here. Because positive x to the right, negative x to the left. Current animation direction equals E animation direction down left. Else if we're doing up now, so y is less than 0.5f, and we get the absolute value of x, and that is less than 0.5. and we don't need to check if it's 0. So if we're moving in a positive y direction and we have a small tiny amount of x on either side, our current animation direction is E animation direction up. Else if y is less than negative 0.5 f and x is greater than 0.5. I'm missing f's here for floats. So we are, yes, we're going upwards. We are going upwards. That's checking this. And we have a little drift. We have a bit more than a drift on our velocity pushing us to the right. To the right, no, I'm not going to do that. Upper right. Else if our y is still going upwards and our x is less than negative 0.5 f, the other direction, current animation direction is, you guessed it, upper left. Just a few more. We're now going to check the absolute value of y this time, because we are checking if there's absolutely no or minimal push now, up or down. So this is for left. So if we have a 0 or if it's smaller, if the absolute value is within that range, and x is greater than 0.0. So if we have any movement left or right, it's going to, only right, or bigger than 0. Our current animation direction becomes right. And then else, if none of that's true, current animation direction is left. Okay. It's just figuring those out is kind of mentally draining. But in comparison to all this garbage, this is a lot nicer. And you could probably figure this out into a switch to clean it better rather than doing all of these, because it's going to check and move on to the next one, move on to the next one, move on to the next one. But this should be fast enough that it really doesn't matter. If you get really anal about it, you can clean it up and figure out how to make it better. So that's our current animation direction. Now to actually animate. Oh, by the way, the reason why you have this, I think, is because of this dynamic. Even if we're not going to be using some of those. Yeah, that's why. You need to have, when you're doing these add dynamics, you need to have the same parameters. It has a float of delta seconds, an f vector of old location, and f vector of old velocity that's passing through all of these delegate calls. So animate has to have those in its signature here, or it will not. It'll get a little squiggly and it'll be mad. So you're going to see I'm not going to use some of these, but they have to exist anyway. So this is where we take, we're going to call that function now off of our old velocity. So the velocity coming in, we call this guy. We set our animation direction. Boom. Our animation direction is now set. If our old velocity, the size of that velocity, if we are moving, we're checking if we're moving again, because we're just gonna bail if we don't need to do this if we're not moving. Switch on current animation direction. Let's go ahead and generate missing case statements and format for each of these. I don't know why it puts the break there. I don't like that. That's better. For for all of these, really. You're going to get the sprite. You're going to set its flipbook, and you're going to get flipbooks.walk up. And you're going to do this for all of them. You're just going to change which flipbook it's grabbing. Clean up. You don't want to clean up? Okay. Switches are funky because these are inside this case, but you don't need bracers. For some reason, somebody decided that. So walk down. Wait a second. Oh! Yes, we're checking. We're checking if we're walking. Duh. Because we have idle and we have walking. So, walk up, walk down, walk left, walk right, walk upper left, walk upper right, walk down left, walk down right. Okay. Default break. And we can get rid of that last break and just fall through. So that is our walking. If our velocity is not, if we've got a smaller velocity than, you know, if we have 0 or else, the size, that is, our velocity, it means that we are standing still. So again, we're going to switch on our current animation direction. Generate all those again. Do it. Do. Sometimes I have things that I like better. We're going to get Sprite, set the flipbook to flipbooks.idle up. And again, idle down. Idle left. Whoop. Idle right. Idle upper left. Idle upper right. Idle down left. Idle down right. And I have a function call over here that may or may not be necessary. I'm going to leave it out. We're going to see what happens if I don't have that. I think we need to set up input. No, maybe not, because we're using a blueprint player character. Let's see what happens. Oh, yes, we are, because I'll call it right here. But it doesn't matter. Let's call it over here. We're going to grab these guys. I'm going to stick them here. You could do this in C++ as well. So let's down here, get rid of our old guy, save everything. Drop our anim character in now. This is our C++ guy. Possess. I want to possess you. No, not components details. Possess. Oh God. Why aren't you working? Let me look through my code and find out. Oh, I bet I know why. I've discovered sometimes doing this in the constructor is not a happy thing to do. The happier thing to do is to do it in the begin play. That might be what's occurring here. And it crashed because we changed things. Don't look at my stuff. There's special secret things happening here. Save. Whoop. Who are you? What's going on? It could be that our player controller issue. Maybe. Okay. We're going to make a player controller real fast, because that's just better. I'm probably calling movement in the wrong place. So let's make a player controller. Input axis up or down. Target, I'm going to get pawn, get controlled pawn. Forget about jump for now. Well, this isn't going the way I wanted. Game mode override. Right. We need a game mode to do this. Game mode base. BP. Game mode. Huh. What is going on? Let's figure it out together, shall we? So, we've got our add movement component input. Oh. Super begin play. Ugh. Oh. You know what? It was working. You know what I forgot to do? This. Which is not set to be able to edit. So that is what I did wrong. We have no flipbooks. Come back over here. Now we can edit them. All right. So we need our idle up, our idle down, our idle left, idle right, idle upper left, whoop, idle upper right, idle down left, idle down right. I'm sure this is fascinating. Lock left, lock right, lock upper left, lock right. Okay, so those are set. Our sprite, we're gonna has it down, save, good. Oop, there you go. That was frustrating. Okay, ta-da! You now have a fully C++ driven animation of a 2D character in a 3D world. To just refresh what was going on there and why stick these in begin play rather than in the constructor function calls or static function calls, I think is what's happening here. It's you don't usually want to call that in the constructor. Somebody else can probably explain better about why that is, but put it in begin play. Don't forget when you have these kinds of things to call the super, so that whatever needs to happen before actually gets happened, and you're not just overriding and ignoring all of that. But yeah, this is it. And in my opinion, this is a lot neater and cleaner. So hopefully this helped, and some people can start making some cool video games or animations, shows, whatever you want to do with this kind of thing. This can be done on NPCs and AI driven too, because we aren't calling this on the movement can be driven from something else. So this base character doesn't have to be just the player character. You can do this for anything and then build your NPCs off of them. And if they move, they're going to be calling this, and they will animate. Just give them their own sprites, and they'll run around in your world. It's pretty cool. I did it. I built a little town of NPCs that randomly walked around. Anyway, yeah. Thanks for watching. I'll figure out what else I want to make next.